Hello students, today we shall see the definition of surface integral, calculation of surface integral, and then some examples. First, what is surface integral? Let f vector be a continuous vector point function. F bar x, y, z. It is a vector point function, continuous, and it is defined at each point on a bounded smooth surface S. And let this surface is divided into m subsurfaces S1, S2, Sm. Surface is divided into m subsurfaces with areas, surface areas delta S1, delta S2, delta Sm respectively. And let first bracket xr comma yr comma zr, these are the coordinates of a point, and this is any point on SR, that is rth subsurface for all r from 1 to 3 m, means x1 y1 z1 taken from S1, x2 a2 z2 point taken from S2, like that. And let nr cap is unit vector normal to SR, normal to the surface SR, nr cap at the point xr y or zr. At this point nr cap is the normal to this surface SR for all r from 1 to n. Okay, then the limit of the sum f vector xr y or zr dot nr cap into delta SR. Function value, vector function value at the point xr y or zr dot nr cap into delta SR, surface area. Limit of this sum as m tends to infinity, number of division tends to infinity, and of course simultaneously largest of delta SR tends to 0, that is each subsurface very small tends to 0, and the limit of this sum, if it exists, is called surface integral or normal surface integral of the vector function f over the surface S, and it is denoted by this symbol, integral symbol over S, f vector dot n cap ds, or sometimes double integral symbol is also given, f bar dot n cap ds, or it is double integral symbol over S, f vector dot ds vector, means n cap ds is sometimes denoted by ds vector. So this is definition of surface integral. And what is n cap? N cap is unit vector normal to the surface at any point on it. Now, how to calculate surface integral? To evaluate surface integral, we first express it as double integral taken over orthogonal projection of the given surface S on the coordinate planes. But this is possible only if any line perpendicular to the chosen coordinate plane meets the surface S in not more than one point. However, if the surface S does not satisfy this condition, then S can be divided into pieces which satisfy this condition. For this, let us assume that the surface S is such that any line perpendicular to xy plane, that is parallel to z axis, meets S just in one point at most. Then the equation of the surface S can be written as z equal to phi of xy. This is z equal to phi of xy. Let D be the orthogonal projection as if shadow orthogonal projection of S on xy plane. This is the shadow of S on xy plane. And if gamma is the acute angle which the normal at any point pxyz to the surface S makes with z axis, then cos gamma ds equal to dx dy. Cos gamma ds equal to dx dy. How? We shall see it. Where ds is the elementary area of the surface enclosing the point P. ds is the elementary area of the surface enclosing the point P, surrounding the point P. Therefore, ds is, from this line, ds is dx dy by cos gamma. Now, what is cos gamma? Cos gamma is mod n cap dot k cap, where n cap is the unit vector normal to the surface at the point P, elementary surface ds at the point P, and k cap is unit vector along z axis, positive direction of z axis we know. See how we have written cos gamma ds is dx dy. This is the surface element, small surface element. Here it is magnified view, and n cap is normal to this surface. N cap is unit vector normal to this surface, and k cap, this is unit vector along z-axis or parallel to z-axis, and the angle between n cap and k cap is gamma. So this surface element is inclined at an angle gamma to the xy plane. This is xy plane, this is x-axis, this is xy plane, if we consider. So angle between n cap and k cap is gamma, means this surface element, small surface element, is inclined at an angle gamma with xy plane. So projection or shadow of this ds, small surface element, on the xy plane is cos gamma ds. Projection cos gamma ds. That's why cos gamma ds is dx dy, because when we project it, ds is oblique, but when we project it, we take its head on xy plane, then we get a plane area, elementary plane area, and elementary plane area on xy plane is always, we know, length into breadth, dx dy. That's why it is dx dy. Cos gamma ds is dx dy, projection of ds on xy plane. And cos gamma is angle between n cap and k cap. That's why mod n cap dot k cap is cos gamma. Modulus of n cap is 1, modulus of k cap is 1. So dot product of n cap with k cap will give us only cos gamma. Okay, and that's acute angle. That's why we have taken modulus. So n cap is unit normal vector to the surface at P, and k cap is unit vector along z-axis. So ds, we have got dx dy by cos gamma means dx dy by mod n cap dot k cap. If we project the surface on xy plane, okay. So therefore our surface integral f vector dot n cap ds over s becomes this f dot n cap ds. We have got dx dy by mod n cap dot k cap. So this ds becomes dx dy by mod n cap dot k cap. But now it is dx dy. So our integral is over the projected domain. This is d in the xy plane. That's why we have written here d. It is double integral. Left side is surface integral, but right side is double integral. Surface integral converted to double integral. And how to calculate double integral we know. Similarly, if d dash and d double dash are projections of s on yz plane and zx plane, here we have projected the surface s on xy plane, and similarly we can project it on yz plane, zx plane. In that case, our surface integral f vector dot n cap ds over s becomes f vector dot n cap dy dz by mod n cap dot I cap. If we project on yz plane, then it is n cap dot k cap, and the surface integral becomes f vector dot n cap dz dx by mod n cap dot j cap. If we project the surface on zx plane. For xy plane, n dot k cap is perpendicular to xy plane. For yz plane, n dot I cap is perpendicular to yz plane. For zx plane, n dot j means y-axis perpendicular to zx plane. So here it is j cap. Like this we remember. So this is calculation process of surface integral. Now let us see one example. Evaluate this surface integral over s f vector dot ds vector, where f is the vector function. F vector is what? Xi cap plus z square minus zx j cap minus xy k cap, and s is the surface of the triangle with vertices 2, 0, 0, 0, 2, 0, 0, 0, 4. These are coordinates of the vertices. Okay, so 2, 0, 0 it is on x-axis, 0, 2, 0 on y-axis, 0, 0, 4 is on z-axis. So this is the triangular area, surface area S, and equation of the plane of the triangle is what? In intercept form. Here it is 2 unit, here 2 unit, and here 4 unit. So it is x by 2 plus y by 2 plus z by 4 equal to 1. This is the equation of the plane of the triangle. If we multiply by 4, we get this. And let us name it 2x plus 2a plus 2x plus 2a plus z. Name it phi xyz. So our surface is phi xyz equal to 4. Level surface. Okay. Now grad phi, del phi, double operator phi operating on phi means it is grad phi. Grad phi is I del phi del x plus z del phi del y plus k del phi del z by definition, and this is here partial derivative of this is with respect to s is 2, with respect to y is 2, with respect to z is 1. So it is 2i cap plus 2j cap plus k cap. This is a vector normal to the surface, all of you know. Grad phi is a vector normal to the surface. If s is the surface, then grad phi is a vector normal to the surface, we know. Already we have done, we have seen. So if we divide it by magnitude of grad phi, then we get n cap. It becomes unit vector normal to the surface. So n cap is grad phi by mod grad phi. That means 1 by 3, because 2 square plus 2 square plus 1 square is 9, root over means 3. So 1 by 3. 3 is the magnitude of this vector. So this is the unit vector normal to the surface S of the triangle at any point on it. The projection of S on the xy plane is the triangular region. Now if we take the shadow of this surface S, oblique surface S, we shall get this. This will be the shadow of this surface on xy plane. This is also a triangular region in xy plane. So we have shown here it is this triangular region. And it is bounded by what? Origin. Vertices of this triangular region are origin 2 0 0 2, because in 3D it is 2 0 0, 2 dimension it is 2 0. Here it is 0 2 0, it will be only 0 2. So that we have written here 0 2. Okay. So surface integral over S becomes ds vector, means it is n f vector dot n cap ds. Okay, this is under notation. Now ds we have projected on xy plane, that's why our ds becomes dx dy by mod n cap dot k cap. So n cap we have found here. If we take dot with k cap, it will be only 1 by 3. So see, we have written 1 by 3 here. Okay, and f dot n cap, f vector we are given, this is f vector, and n cap just we have found this is n cap. So if we take dot product, coefficient of I, coefficient of j, coefficient of k, just multiplied. So this is the value of n cap dot k cap, and this is dx dy by 1 by 3, means mod n cap dot k cap is 1 by 3, and there is already 1 by 3 is there. So this 1 by 3 and this 1 by 3 gets cancelled. Now it is a double integral over the region D. This is our D, double integral over the region D. Surface integral converted to double integral over the region D. And now on this surface, actually z is what? 4 minus 2x minus 2y. See, this is our equation of the surface. So z is 4 minus 2x minus 2y. So this z is replaced by 4 minus 2x minus 2y. Okay, because we are taking surface integral over the region S. That's why when we go to plane region, our z should be replaced by first as obtained from the equation of the surface, z minus 4 minus 2x minus 2y. So that we have taken here. Z is C 4 minus 2x minus 2y square, this z square, and this z we have written 4 minus 2x minus 2y, and then simplified. And for this region D, this region, plane region D, will be described by vertical strip y from 0 to 2 minus x, because the equation of this line is x plus y equal to 2. X plus y equal to 2. This line actually, this is x plus y equal to 2 line. Okay, so y from 0 to 2 minus x, and then x varies from this point, means origin, means x equal to 0 up to this. Up to this means here it is x equal to 2. So that we have written here, x from 0 to 2, y from 0 to 2 minus x. And then what we have done, we have simplified it and integrate with respect to y first. After all simplification, what we have done here, 4 minus 2x minus 2y, what I have taken 2 common, means 4 common, so it becomes 8. So x plus y minus 2 whole thing square, we can integrate it with respect to y easily. So integration of this with respect to y will be 2 minus y square by 2 with a minus sign, because coefficient of y is minus 1. Okay, similarly integration of this will be x plus y minus 2 to the power 3 divided by 3. So that we have written here. Okay, partial integral as if with respect to y. So we have integrated, and then y from 0 to 2 minus x, upper limit 2 minus x, lower limit 0, we have substituted, simplified, and finally it is integrated with respect to x, and upper limit 2, lower limit 0. So these calculations you will see yourself, and final answer is 10. Okay, so converting the surface integral to double integral we have calculated. Now next example, show that surface integral of f over s f vector dot n cap ds is equal to 3 by 8, where f vector means this is vector function given s is the outer surface of the sphere x square plus y square plus z square equal to 1 in the first octant, means it is sphere, unit sphere, center, origin, radius 1, but the surface we have to take in the first octant, positive octant. So this is the surface. It is not full sphere, it is in the first octant, positive octant s. So equation of the surface s is, this is the equation of this sphere. From this we let us name it phi x y z equal to 1, means phi x y z is x square plus y square plus z square. So grad phi, I del phi del x, z del phi del y, k del phi del z we know. So 2x, 2y, 2z will be coming here and 2 common. Now unit vector normal to the surface at any point x, y, z is n cap is grad phi divided by mod grad phi. So here modulus of this will be root over x square plus y square plus z square. Okay, and 2 by 2 so cancels. Finally it is this. This is our n cap unit vector. Therefore also mod n cap dot k cap is n cap dot k cap. If I take dot product with k cap, it will be z. So mod z is z because z is always non-negative in the first octant. Our region of integration is, or surface is in first octant. So mod z means only z. Therefore our surface integral is equal to double integral over d f dot n cap dx dy by mod n cap dot k cap, where d is the projection of s on xy plane and it is in the first quadrant of, it is the first quadrant of the circle. This spherical region, if we project spherical region, this spherical region if we project on xy plane, shadow of this spherical region on xy plane will be quadrant of the circle. This is circular. Okay, radius on center origin. So this we have written here, and if we want to describe by polar coordinates, theta will be 0 to pi by 2, r will be 0 to 1 for this. So therefore our double integral over d, this is double integral right side over d, surface integral converted to double integral, f dot n cap, this is f vector, this is n cap, and dx dy by mod n cap dot k cap, already we have seen z. So dot product taken, coefficient of I, coefficient of j, coefficient of k, multiplied and added. So this is dot product, all of you know. And then one z is common, yes, z, and this z gets cancelled. So this becomes simple. And then x is r cos theta, y is r sin theta. In polar coordinates we have taken x r cos theta, y is r sin theta, changing the variables from xy to r theta. So Jacobian will be r, means dx dy will become r dr d theta. We know ranges of values of r and theta are obviously 0 to pi by 2 theta and r from 0 to 1. Okay, so this is the double integral 0 to pi by 2, 0 to 1, x 3 taken out, r cos theta x, r sin theta y, and dx dy is r dr d theta. Now the limits are constant and functions are also separable. So all function of theta, integration with respect to theta 0 to pi by 2, and here it is only r cube, integration with respect to r 0 to 1. So simple integration. Sin theta cos theta integration is, if I take sin theta as t, then it is dt, cos theta d theta is dt. So t dt means t square by 2. So we have written sin square by 2, 0 to pi by 2, and here r cube means r to the power 4 by 4, 0 to 1. So it will be 1 by 4, and here it will be sin pi by 2 is 1, so 1 by 2, and here 4, 8, so 3, ultimately 3 by 8 is the answer. So this was the question showed. Now one note what we have written, if f vector is f I cap plus g j cap plus h k cap is a vector function of position x, y, z defined on a smooth surface S, and n cap is cos alpha I cap plus cos beta j cap plus cos gamma k cap, unit vector normal to the surface, cos square alpha plus cos square beta plus cos square gamma we know 1 if alpha beta gamma direction angles of the vector. Okay, cos alpha cos beta cos gamma direction cosines means element, so L square plus M square plus N square equal to 1 we know for direction cosines. Here it is cos square alpha cos square beta cos square gamma, when we added we get 1. So this is unit vector. Okay, at any point x, y, z on the surface, then the surface integral of f vector over S is given by surface integral f vector dot n cap ds. This is f vector, this is n cap. Okay, now if we take dot product, it is coefficient of I multiplied, coefficient of j multiplied, coefficient of k multiplied and added. Dot product all of you know. So f cos alpha g plus g cos beta plus h cos gamma ds. Now cos alpha ds already we know dy dz, cos beta ds we know dz dx, cos gamma ds dx dy. This was proved in one of the previous discussion. We have seen cos gamma ds is dx dy. Similarly cos beta ds is dz dx, cos alpha ds is dy dz. Means projection of the elementary surface area ds on xy plane, zx plane, yz plane. Okay, so this cos alpha ds becomes dy dz, cos beta ds becomes dz dx, cos gamma ds becomes dx dx. So this is Cartesian form of the surface integral. Cartesian form of the surface integral. Here it is vector form, this is Cartesian form. Okay, now next example, evaluate surface integral of this f vector, where f vector is this and s is the portion of the plane x plus y plus z equal to 1 included in the first octant, means positive octant. So here equation of the surface is x plus y plus z equal to 1, means phi x y z equal minus 1 equal to 0 you can write, or phi x y z equal to 1 you can write. Okay, phi x y z we have taken x plus y plus z minus 1, so phi x y z 0. Now grad phi is I del phi del x plus z del phi del y plus k del phi del z partial derivative, so it is I plus j plus k, obviously because derivative of x, y, z with respect to x, y, z respectively are 1 1 1. Okay, so unit vector normal to the surface at any point x, y, z on it is, and cap is grad phi by mod grad phi. Here it is 1 1 1 means coefficient, so 1 by root 3 if we divide it is unit vector. It is constant vector, not depending on the point x, y, z, everywhere it is same. So given f vector is this, so f vector dot n cap, this is n cap we have got, so take dot product, 1 by root 3 will be there, coefficient of I, j, k multiplied and added, so it is 12 x square y minus 3 yz plus 2z, and n cap dot k cap is 1 by root 3 because here k cap is there, so if we take k cap dot with k cap only 1 will be coming here, 1 by root 3, so got there. And now let d be the projection of the surface s on the xy plane. This is our surface s, oblique surface, triangular surface on the plane, which, and if we project it on the xy plane we get another plane region that is also triangular, which is the triangular region bounded by x-axis, y-axis. This is x-axis, this is y-axis, and this is the line x plus y equal to 1, because x plus y plus z equal to 1, when it meets xy plane we put z 0, so we get x plus y equal to 1. Then this is in the first quadrant for two-dimensional region D, and therefore surface integral becomes this double integral over D, and ds becomes dx dy by mod n cap dot k cap. Mod n cap dot k cap is 1 by root 3, already we have calculated. This 1 by root 3, this 1 by root 3 gets cancelled. So finally, and of course on this surface z is 1 minus x minus y, z is 1 minus x minus y 1s, so this z is to be replaced by 1 minus x minus y, we have replaced, and then integrated with respect to some simplification we have done, and say limits for x 0 to 1 and limits for y 0 to 1 minus x. See, if we take this strip here, so y will be here 0 and here y is 1 minus x. X plus y 1 means y is 1 minus x. So limits for y is 0 to 1 minus x, and limit for x is 0 to 1 here, because in intercept form the plane meets x axis at 1 0. So this is the 1 unit length here. Okay, so first we integrate with respect, here we have simplified it and integrate with respect to y, partial integration keeping x constant. So what will be there, y square by 2 coming here, y cube by 3 means 3 cancels, and this will be 2xy 2y, and y from 0 to 1 minus x. So upper limit 1 minus x, lower limit x 0 you have substituted, and then please simplify yourself, and finally integrate this line with respect to x, and then put upper limit 1 lower limit 0 and simplify, you will get 139 by 120. These are only calculations you have to do yourself. Next example, evaluate surface integral over s f vector dot n cap ds, where f is this and s is the surface of the plane 2x plus y equal to 6 in the first or positive octant cut off by the plane z equal to 4. One plane, another plane in the positive octant. See, 2x plus y equal to 6. 2x plus y equal to 6 will be a straight line like this in the xy plane. 2x plus y, if I take intercept from it will be x by 3 plus y by 6, means 6 unit from y axis and 3 unit from x axis it cuts. Straight line 2x plus y equal to 6. But when I consider 2x plus y equal to 6 in 3D, this is not simply a line, it is a plane. So it is plane, z from minus infinity to plus infinity, so that's why it becomes plane. whatever given in the figure. This line becomes plane, it moves up. Okay, and our region is surface is in first octant. So here z equal to 0. So I have mentioned z 0. Up to what? Up to cut off by z equal to 4. So we have to go up to 0 to 4. So this is z equal to 4. Z equal to 4 height. We have to move from z equal to 0 to z equal to 4. Okay, in the positive octant. So this is the surface S, like a rectangle. Okay. Now equation of the surface is here, phi xy z is 2x plus y minus 6 0. Z is absent here. Okay. Grad phi I del phi del x plus z del phi del y plus k del phi del z we know. So here del phi del x is 2, del phi del y is 1, del phi del z is 0. So I have written here 0 kk. So this is our grad phi, and divided by modulus you will get mod grad phi, you will get unit vector. So it is 2 square plus 1 means 5, so 1 by root 5, 2ik plus j cap is the unit vector normal to the surface. This is the unit vector normal to this surface. This is n cap. This is our surface, plane surface. Okay. Now f vector is given, and now take f dot n cap. So this is n cap, take f and n cap dot, coefficient of I multiplied, coefficient of j multiplied, and added k coefficient is absent here, so j will not be coming. So it is 2 by root 5 x plus y, f dot n cap. Now let d be the projection of s on zx plane. See, this rectangular surface, when we project on zx plane, it will be like this rectangle, shadow of this s on the zx plane will be another rectangle, whatever shown is d. This is d, z0 to z4 and x0 to x3, obviously, because see, this is 2x plus y equal to 6. If we take in intercept term, it will be x by 3 plus y by 6. So that's why here it is 6, here it is 3. So x from 0 to 3 and z from 0 to 4, obvious. So d with the projection of s on zx plane, and we note that the plane 1 is parallel to z axis. Yes, z is absent here, means it is parallel to z axis, minus infinity to plus infinity, but our range is given 0 to 4. Why 0 to 4? Because in positive octant starts from z0 and goes up to 4 as per question. Okay, and that is perpendicular to xy plane. This surface S is parallel to z axis. This surface S parallel to z axis, so surely perpendicular to xy plane, as in figure, which is a rectangular region on zx plane bounded by z equal to 0, z equal to 4, x equal to 0, x equal to 3. These are the boundary of this shadow of this surface on zx plane D, and therefore this surface integral becomes double integral over D. This time it is on zx plane, projected on zx plane. That's why dz dx by mod n cap dot j cap. Okay, already we have seen. When we project on zx plane n cap dot j cap, when we project on xy plane n cap dot k cap, when we project on yz plane n cap dot I cap. Okay, so n dot j is this is n cap, this is j dot, means only 1 by root 5. So this becomes f dot n cap, already we have calculated here, and now dz dx by this n dot k modulus will be, again if I take mod here, it will be 1 by root 5, modulus is also 1 by root 5, no problem, positive. So this root 5 and this root 5 gets cancelled, and finally there is no D is on zx plane. So y is to be eliminated. How to eliminate? We have equation of the surface S is 2x plus y equal to 6. So y equal to 6 minus 2x. So this y we have eliminated because we have projected on zx plane, and earlier problems we have eliminated z because we have projected on xy plane. Here we have projected on zx plane, that's why y is to be eliminated from the equation of the surface, and then integrated with respect to z first, z from 0 to 4, okay, and then x from 0 to 3. But here see, there is no mixture, it is function 6 minus x only. We have to integrate 6 minus x with respect to x, and there is no z here, so only dz z0 to 4 we have integrated separately. This double integral expressed as repeated integral, and then it is z 4 0 upper limit 4 minus 0, here it is 6x x square by 2 upper limit 3 lower limit 0, you put calculate and get 108 as the answer. So this is what surface integral and some examples we have solved. Thank you for today.